Question number 1. What is the acceleration of a 0.3 kilogram volleyball when a player uses a force of 42 newtons on that ball? So first of all, let's draw a picture. When I'm dealing with Newton's laws and forces in general, I typically start with a picture. So I have this volleyball, and I'm going to apply a force on that volleyball from a hand, I know it's not a very good hand, of 42 newtons. Okay? The mass of the volleyball is 0.3 kilograms, and I'm trying to determine what the acceleration is. Now, for simplicity's sake, I'm going to ignore the weight. Remember, when we're referring to weight, we're referring to the force of gravity. I'm just going to concentrate entirely on the force that's being applied by the hand and the mass of the volleyball, and not including the additional force of the weight, which would definitely change the acceleration. Okay, so Newton's second law says that the sum of all the forces that are acting on that object produces an acceleration. And that acceleration is inversely proportional to the mass, which basically translates to this. Okay? Sum of forces equals mass times acceleration. Okay? Cool? So the sum of the forces on this is 42. Once again, I'm only considering the force by the hand, not the force of gravity, because then I would have to add that term to it. Okay? Is equal to 0.3 kilograms, and that should go 0.3 kilograms, times A. Okay? Solving for A, I move the 0.3 over to the other side, and I'm left with 42 divided by 0.3 Newton per kilogram. Well, that translates into a meter per second. Okay? From there, I just break out my calculator and say 42 divided by 0.3 equals 144. So the acceleration of my volleyball is going to be equal to 140 meters per second per second. That's how much speed, that's how much its velocity will change in a second. So if I can apply this force of 42 newtons on that volleyball for a second, and it's at rest, its final speed would be 140, or its change in its speed, or change in its velocity would be 140 for that 1 second. Now, when we strike a volleyball, we're definitely not striking a volleyball for an entire second. That's going to be a considerably shorter period of time. But that's how you solve this problem.